And I got an error here. So in using Matlab, you must also be very careful with the data type. Since T here is, there is already a variable T, which is a numerical array or numerical vector. So if you use this one, certainly it will give an error message. And the correct form is you better code this expression as and express it as a symbolic expression. So in that case, the T here is not the same as the numerical T existing in the Matlab space. So the two function codes are different. Alternatively, if you specify T as a symbolic variable, then you can use this command. There shouldn't be any problem. Because I have already a variable T which is a numerical vector, and if I use the function directly, there is an error. So this is the numerical integration. So what is the definite integral at these 2 points in the interval A and B? Sorry, this one is, I think this one is wrong. This one is wrong. I should point it out, I will explain that one later to you. It should be pointed out that if you equal fn int function or the earlier fn ber function, what you obtain is another object. So fi is an object. If S is a cubic spline object, then fi is a cubic spline. If fi is a B-spline, then fi should be another B-spline function. So what is the definite integral over the interval A to B? If you have already an object like this, which is the integral object, S-spline object, then you can use a command like this, fnval command like this, 0 to pi. If you use the command like this, you can find the interpolation result of A at point 0 and point pi. So you can have two numbers. The results are given by two numbers. So you can extract this number from this number. This is the, well, it's better explain it in mathematical form. fnval SAB, where S should be SI, which is the first order integral. This one will return F A and FB, which are the integral functions. So the result of definite integral within the interval A and B should be FB minus FA. So this should be the result of our definite integral. So you have two numbers here. The definite integral should be the difference between them. So you can use DFF to find the result. And this is the command I used in the PPT file. So with the use of cubic spline function, you can easily find the integral, definite integral. The theoretical value of it should be 2. But since you only know 5 points for the sample at the sample point, so the integral you find has some errors. So there is an error of 0.0191. So this is the error. And if you are using a B-spline function and you perform the same command, you will see that the definite interval is much closer to the theoretical value. So in real application, I would suggest you use B-splines. So any problem here? We can help with here. Any problems? And the rest part of the lecture is like this. I can explain something in chapters 8 and 9. After that, if anybody is still interested, I shall talk about graphical user interfaces, how to design graphical user interfaces in that. It may last longer than I have expected then. So should we have a break here?